In this last video, we're going to compare the three models of oligopoly that we've covered. So first Collusion, then Bertrand, then Cournot. For each of these problems, we're going to work through the same market. So we'll have the same demand curve. There's going to be two firms, and both of those firms are going to have the same total cost equation. So we'll have firms A and B. They're going to be facing a market demand curve of price equal to 350 minus 5 times quantity, where market output is the sum of the two firms' output, right? So quantity produced by firm A plus quantity produced by firm B. And then their total costs are going to be the same of 25 times quantity. Okay, so again, we're going to start with collusion. We're going to find the market output, market price, and profit total in the market. And then we'll turn to Bertrand, find the same values, and then lastly Cournot and find the same values. All right. So starting with collusion. Our firms that are colluding are going to act as if they are a single firm, a single monopolist. So we're going to take the given demand equation and find the marginal revenue curve from that. So we'll have price equal to 350 minus 5 times quantity. We're going to double that coefficient on quantity to find the firm's marginal revenue curve when they act like a cartel. Next, we need to find their marginal costs. We're given that their total costs are equal to 25 times Q. Marginal costs we find just by taking the derivative of total costs with respect to output, and it's going to be constant at 25. So setting marginal revenue equal to marginal costs, we get 350 minus 10 times Q equal to 25. Next, we're going to subtract 25 from both sides and add 10Q to both sides. So we get 325 equal to 10 times quantity. And then we divide both sides by quantity. So we have 32.5 units produced in this market. So there is our market output. Next, we need to find the price. So we're going to substitute for output in our demand equation. So again, our demand equation is price equal to 350 minus 5 times quantity. Substituting for output, we get 350 minus 5 times 32.5. 5 times 32.5. All right, let's see what that gets us. Going to get us 162.5. So we'll have 350 minus 162.5. And that's going to leave us with a price of $100 and $187.50. That is the market price for this collusion market, right? This cartel. Lastly, we need to find the profits in the industry. So profit, again, we're going to find using that same formula, price minus average total costs times output. Average total cost is equal to total cost divided by Q. Total costs are 25 times output divided by output gives us constant average total cost of 25. So we're going to get profit equal to 187.5 minus 25 multiplied by 32.5. Okay. So 187.5 minus 25 is going to get us 162.5 multiplied by 32.5. This is a 6. Ooh. All right. 162.5 times 32.5 is going to give our cartel firms a total profit of $5,281.25. So $5,281.25. This profit is split between them, just like the output is going to be split between them. So let's go ahead and put our values into our table. So for collusion, they are going to have a total industry profit of $5,281.25. The price that they charge in the market is going to be $187.50. And then output is going to be 32.5 units. Next, let's look at if these two firms were engaged in Bertrand competition. So for Bertrand, what we need to keep in mind is that they are competing on the margin of price, meaning that they're going to be undercutting each other until they hit the price that equals their marginal cost, because that's as low as they can go. If they go any lower, they're earning negative producer surplus, at which point they're just going to stop operation entirely, okay? So what we can go ahead and do, since we've already found that the firm's marginal cost is the same across the two and it's constant at 25, and we're given their demand equation of price equal to 350 minus 5 times Q, we can go ahead and just set price equal to marginal cost and solve for output. So price equal to marginal cost is going to get us 350 minus 5Q equal to 25. We're going to subtract 25 from both sides and add 5Q to both sides. So we get 325 equal to 5Q. Dividing each side by 5 gives us output of 65 units in this market. The price that they charge, right, it should be equal to their marginal cost. Let's just check. So it should be 25. If we substitute for a quantity in the demand equation, we get 350 minus 5 times 65. 5 times 65 is 325, so we get 350 minus 325, and that leaves us with a price of $25 in the market. And then lastly, we just need to find their profits. We're going to use that same equation, price minus average total cost times output. We know that the price for our firms engaging in Bertrand competition is going to be $25. Their average total cost is the same as their marginal cost at 25, and their output is 65 units. 25 minus 25 gives us 0, times 65 is clearly 0. And so the market price for our Bertrand firms, the market profit for our Bertrand firms is $0. So let's go ahead and put that into our table. So Bertrand firms earn 0 profits. They set a price of 25 and they produce 65 units. Lastly, we want to look at if our firms engage in Cournot competition. So for Cournot, let's actually real quick make it so you can see the differences a little better. Okay. All right, for Cournot, we're really going to take advantage of that fact that our firms are competing on the margin of output. And so we want to rewrite our given demand equation to reflect that. So initially we're given 350 minus 5 times output in the market, where market output is equal to what firm A makes plus what firm B makes. Okay. So we're going to go ahead and rewrite that demand equation such that it's reflective of that summation. So we'll have price equal to 350 minus 5 times quantity produced by firm A plus quantity produced by firm B. We'll then distribute that -5, so we get 350 minus 5 times quantity sub A plus, minus 5 times quantity sub B. From here, we're going to find each firm's residual marginal revenue curve. So I'm going to double the coefficient on modifying the quantity variable for each firm in turn. All right. So when we're finding the marginal revenue for firm A, that'll be 350. Then we double that coefficient on the output of firm A. So we have 350 minus 10 times quantity A minus 5 times the amount produced by quantity B. By firm B. So you can see we only doubled the coefficient, modifying firm A's output when we're finding firm A's residual marginal revenue curve. We're going to do the same for firm B. So the marginal revenue for firm B is given by 350. minus 5 times quantity produced by firm A minus 10 times the quantity produced by firm B. So again, you can see we only doubled the coefficient, modifying the output produced by firm B because we're finding the marginal residual curve for firm B. Okay. Next, we're going to set marginal revenue equal to marginal cost for each firm. So we'll have the marginal revenue for firm A equal to their marginal cost. Both firms, like we found before, have a marginal cost constant at 25. So we'll see that their marginal cost will be the same. Okay, so we're going to start with firm A. We have marginal revenue for firm A equal to marginal cost. That's going to give us 350 minus 10 times the amount firm A produces, minus 5 times the amount firm B produces equal to 25. For firm B, just setting up our equation, we have 350 minus 5 times the amount firm A produces, minus 10 times the amount firm B produces equal to 25. So let's focus on the left-hand side and just solve for firm A now. We're going to add 10 times quantity sub A to both sides and subtract 25. So we're going to get 325 minus 5 times the quantity produced by firm B equal to 10 times the quantity produced by firm A. From here, we're going to divide both sides by 10. That's going to give us 32.5 minus 1/2 times quantity produced by firm B. Let's actually make that a decimal so our equation is consistent. And that's going to equal the quantity produced by firm A. So this is firm A's reaction curve. Let's find firm B's reaction curve. We're going to subtract 25 from both sides and add 10 times the quantity firm B produces to both sides. That's going to give us 325 minus 5 times the amount produced by firm A equal to 10 times the amount produced by firm B. We're going to divide both sides by 10. That's going to give us 32.5 minus 0.5 times the amount produced by firm A equal to the amount produced by firm B. And now we have firm B's reaction curve as well. Now we're going to use these two reaction curves to solve for the exact amount that each firm produces. So I'm going to take the equation for quantity produced by firm B and use that to substitute for quantity sub B in firm A's reaction curve. So doing that substitution, we're going to get that the amount that firm A produces is equal to 32.5 minus 0.5 times 32.5 minus 0.5 times the amount produced by firm A. Now we'll distribute that negative 0.5 into the parenthetical. That's going to get us 32.5 minus 16.25 plus 0.25 times the amount produced by firm A. From here, we're going to simplify. We're going to subtract 16.25 from 32.5, and we're going to subtract 0.25 times quantity sub A from both sides. That gets us 0.75 times quantity sub A equal to 16.25. Okay. Finally, we're going to divide both sides by 0.75, and that is going to give us a quantity produced by firm A equal to 21.67 when we round to the nearest hundredth. If you were to have this in fractions, right? Usually I like to work in fractions. We didn't in this case. This is going to give you a fraction of 65/3. Okay. Now that we have the amount that firm A produces, we want to find how much firm B produces. So we're just going to substitute into firm B's reaction curve for the amount produced by firm A. So the amount produced by firm B is going to equal 32.5 minus 0.5 times what firm A produces. Simplifying, we're going to have this negative 0.5 multiplied by 21.67 first. That's going to give us 32.5 minus 10.84. Doing that subtraction is going to give us 21.67. So we can see that they're each producing the same amount. And for quantity from B, I'm also, of course, rounding to the nearest hundredth. Now that we have how much each produces, we can find the market output. So we're just going to add what firm A produces to what firm B produces. So we're going to have 21.67 plus 21.67. That's going to give us 43.34, right? Or you could do 43.33, depends how you round. And that is going to give you market output. Now that we have market output, we can find the market price. So our market price is going to be given by 350 minus 5 times 43.34. That's going to give us 350 minus 216.7, which ultimately gives us a price of $133.33. Last thing we need to find is the market profit. So profit here is going to be price minus average total cost times market output. We know average total cost is constant at 25 because we found it before. The price in this scenario is, sorry, this shouldn't be price of 33. It should be 30. Okay. It depends again when you round, how you round. So price is 133.30 minus 25 times 43.34. So 133.3 minus 25 is going to leave us with 108.3. And we're going to multiply that by 43.34. And that will give us profits for this industry of $4,693.72. All right. So let's just go ahead and write our values into our table here. So profit is going to be, if we go all the way back up, $4,693.72. We found that the price charged by the firm is going to be, each firm in the market is going to be $133.30. And then each firm is going to produce 43.34 units. All right. So here are all our values. So what I want you to notice here is which of our oligopoly models is furthest from perfect competition, closest to monopoly, and which is the most competitive, right? Meaning most closely like perfect competition. All right. So what we're going to see is when we compare output, we're going to have that the output under collusion is the lowest. So it's less than the output produced by Cournot firms, which is less than that produced by Bertrand. And that produced by Bertrand is actually going to be equal to the perfectly competitive quantity. Okay. If we look at price, the price that the collusion charges is going to be the highest, followed by the price that Cournot firms charge, followed by the price that Bertrand firms charge. So again, Bertrand is going to be equal to that perfectly competitive output. And collusion, as long as the cooperation is perfect, there's no cheating, they're going to be the same as monopoly. And then lastly, for profit, the firms who are colluding, again, assuming there's no cheating, have the highest amount of profit in the market, followed by that produced by Cournot firms. And then, of course, last is the firms who are engaging in Bertrand because they make no profit whatsoever. All right, so you can see there how those values relates, with collusion being most like monopoly and Bertrand being most like perfect competition. Okay. And these relationships are summarized on in the lecture slide deck. All right, so you can see that there as well. That output produced by Cournot is the same as that monopoly output. By collusion is the same as the monopoly output, which is less than that produced by Cournot firms, which is less than what Bertrand firms produce. Right? When it comes to price, Bertrand firms price the lowest, which Cournot prices just above that, and then the prices charged by the colluding firms are the highest. And then finally, for profit, Bertrand firms earn zero profit, which is less than what Cournot firms earn, which is less than what colluding firms earn, because those colluding firms, again, assuming no cheating, are earning monopoly profits the highest possible. Okay. So with that, we're going to end our coverage of oligopoly, and we'll do some more practice problems in class.